Hey, everybody. Welcome back to the podcast. I'm Chris, your host, and I've got Ram Srinivasan again with me, author of The Conscious Machine, global head of AI at Jones Lang LaSalle. Ram, thank you.
Thank you. Thank you for having me on again and look forward to this conversation. We had a nice, fun discussion last time around and we went across so many different areas, Chris. I'm looking forward to exploring more of them with you and the listeners of the Edge Report.
Yeah, well, thanks again for doing it. I appreciate it. We're in season 3 and so much change continues to be abound. So let's just start it with where we are now. Like we'll frame this kind of as a AI built environment moment, like we were just talking about backstage. You know, infrastructure, just like our cities were built with roads and some organization in mind. Right now, we've got this invisible infrastructure of data, chips, and governance and models. And a couple of weeks ago, you and I went back and forth on this new Swiss AI initiative, serving as a different kind of urban planning. Let's talk about that a little bit. Maybe you could introduce it to the listeners and let's go from there.
Yeah, sounds good. And I do have a couple of slides here, and I'll maybe begin with a little bit of around the world in AI and exponential tech. There's just so much happening. I think it's good to kind of ground our listeners in that. So let me bring that up.
Sure, that sounds great.
Let me know once visible.
There you go.
Okay, awesome. So just a lot happening around the world, and I always like to talk about the real and the tangible. So it's fascinating that Wall Street has kind of recognized that the big tech investments into AI, into talent, and into real world performance is really being rewarded right now. So if you look at any of the large tech companies, they've done well in their quarter returns, and Wall Street has kind of recognized that. So I see it as a positive sign. Like you mentioned, Chris, we're just building the first stage of infrastructure, and on this initial stage, there'll be a lot more innovation. And one of those is Devon AI. For listeners of the Edge Report, Devon AI is an autonomous software engineer. And Devon, by the way, is actually on LinkedIn. You can connect with Devon and you can hire Devon for $20 a pop. This is an autonomous AI agent.
Yeah, it's cool.
Yeah, really cool, from Cognition Labs. And also interesting that, so a number of the Wall Street banks are testing with Devon. So you have Goldman Sachs, you have Citibank testing with Devon right now. And then, third key trend that I'm seeing is around pilots and pilot assessments and those kind of things. I would say 2024 was a year when a lot of companies started testing enterprise productivity applications, and that is scaling right now. Then agentic AI is in the pilot testing phase, and a lot of companies have recognized that, look, it's very easy to build an MVP with some of these no-code AI applications and tools, but it's tough to scale it into production environments. And this notion of, let 1,000 flowers bloom and have thousands of AI POCs and test cases, that's not working at least for enterprise grade applications. So there's consolidation happening, there is more prioritization happening, there's more of a surgical effort to drive towards ROI focused initiatives. So that's kind of a critical trend we are seeing. Then tremendous model innovation happening. We are seeing AI models saturating benchmarks. So there's this question on, do these benchmarks even hold water anymore? Do we need a new type of benchmark? Do we need a benchmark that says what global good does this AI model do? What innovation is it creating? Is it helping our society? Do we need those kind of benchmarks? OpenAI and Google DeepMind also won International Math Olympic gold recently. Again, cool feature there, Chris, and there are so many threads here. Within the International Math Olympiad, there are 6 questions. Both of these models got 5 out of 6 right. One of those questions requires tremendous creativity beyond hardcore math, those kind of things. So I'd be curious to learn more as we go further. Did these models crack that creative problem, or were these the other problems? So that's an interesting element.
It is.
Google also released Alpha Evolve since we last spoke, which is a model that kind of reprograms itself, for lack of a better word, and can improve itself. So very interesting development there. Microsoft also did assessments on a new technique called chain of debate, where the models debate with each other and come up with a much better, robust solution. They're calling it medical superintelligence. These super intelligent models outperform doctors in real world cases. So really interesting development.
Yeah, that was some crazy, like 80 something percent outperformance.
85%.
Yeah, I mean, high outperformance, not just edging.
Yeah, incredible. And then not to forget that this is not just AI, it's also applications beyond AI. So, for example, Alibaba released or is proposing an AR glass solution similar to Meta's Ray-Ban AR glasses. Apple's also spoken about similar kind of development. They also released Gwen 3, not to be left behind. China and innovation in China is also doing incredibly well on the AI front.
Yes.
Then you also had this. If I were to pick one of these developments, the next one is my favorite one, which is ChatGPT Tutor Mode and Notebook LM Video.
Yeah.
Yeah, they're just incredible. For anyone who hasn't used either, please go and do it right after you listen to this podcast.
All right,
Uh,
we'll take a note on that for sure. ChatGPT tutor mode with Notebook LM.
it is incredible. Notebook LM Video Mode, basically you can upload any text content and it'll convert it into a narrated presentation for you. So like, it's just fascinating how you could rethink education, training, various other things. Meta, of course, is on a hiring spree. We've seen that talent density, compute density meet each other at Meta super intelligent labs. So this is a massive development as well.
Ram, they're gonna hire me for $100 million a year.
Yeah, some of the salaries are crazy. I heard I was reading yesterday that there was a 200 million offer. There was also $1 billion offer, by the way, which was declined. Is my understanding.
Available just for the whole public to know. Just so everyone knows.
This is because this has been branded the battle for the 1,000 AI minds, and the way I see it is actually the innovation will happen beyond those 1,000 minds. So these 1,000 minds are just building the infrastructure, which is incredible innovation in and of itself. But beyond that, each one of us will have the power of those tools, and we could do much more.
Right.
And this is that spectrum of human plus machine. Microsoft spoke about this in their frontier firm research, where they said, you are no longer managing just a human workforce; you're also managing an agentic AI workforce. You are the agent boss, and
Right.
how do you leverage those technologies to your benefit is going to be incredible. Also, just a sneak peek on GPT-5, GPT-5 reasoning. It's imminent, and kind of early testing shows, no surprise that it will be the frontier model, beating right now Grok 4 and let's say some of the Claude 4 larger models. It'll beat those models, and then we will see, I'm sure, model releases from the other labs as well. So this is kind of a never-ending race upwards. And the last thing I'll mention here is cybersecurity risk, which is also increasing. Um, Massive increases there in shadow AI use. Shadow AI is basically you use an AI model or tool that is outside the realms of your organization's cybersecurity policy. And shadow AI use has increased um, beyond what anyone would have thought. Document uploads to ChatGPT are up 156%. 85% of the knowledge workforce claims they have used shadow AI tools, and it costs companies millions a year. So, we are the weakest link, so to speak, in the security chain going forward as humans. And this brings us to, okay, this is all amazing innovation, but is it benefiting us as a society, or is it benefiting few?
Right.
And that's where what we discussed on one of our previous exchanges was around the Swiss AI model, and the model being one for greater social and public good. They're calling it the pro-social AI, and the way they characterize it is the catalyst for human flourishing and planetary well-being. I mean, big themes,
Oh yeah.
and it's actually built on four key pillars, what they call the 4Ts model. So it's a heavily tailored system. Swiss AI model heavily tailored to specialist areas like science, education, robotics, climate studies, etc. The training architecture, training documentation, training data is will be fully disclosed. So this is in contrast with other models. So broadly you have closed models like OpenAI or Claude or any of these models are closed models. We don't know what data they're trained on specifically, the model architecture, or any of those things. We have some idea, but not too many details. Then you have open weights models like the Llama models from Meta, where you know the weights of the model. So if you think about the model as a weighted average formula, you know the weights of the model, you know the parameters, something like this. Um, Open source is very different, where you know the documentation, you know the architecture, you know exactly how the model was trained, you know a fair degree of detail on all of those elements, and that's what the Swiss AI model is doing. It is heavily tested for safety, bias, those kind of elements, and it's very focused and targeted. So as opposed to the other labs which are creating generalized intelligences, this will be more specialized. So it's a fascinating development. It's also, what I found interesting was it's massively multilingual, trained on 1,500 odd languages, will output 1,000 odd languages. 60% of the training data is English, 40% is other languages. You also have computer code and those kind of things in the training data. It's built and hosted on the Swiss Alps supercomputer. It's a carbon neutral supercomputer. Again, brilliant amalgamation of sustainability, AI infrastructure, which is a huge topic of interest for a lot of folks. And like you mentioned, Chris, in the opening, it offers it's an alternate to regulation heavy environment or completely free environment. It's kind of this nice middle path. It's a principles based approach, and you could see the benefits of it. There are also challenges, and it would be good to have your perspective on this, Chris. Couple of things which I see are kind of the complexity versus safety. A thing that's so complex, can it be truly safe? I'm not sure. And then you have the bitter lesson in AI. For those who are not familiar with it, basically what the bitter lesson in AI tells you is that a general model, in kind of a general sense, will outperform a heavily engineered model. And it simply keeps scaling as opposed to doing first principle based engineering. And this is proving itself out. Grok 4 is trained on the heaviest teraflops, and it's outperforming all of the other AI models. And Grok with X have caught up the other labs very, very quickly just on that principle. So lots of ideas to discuss. I thought I'd just give a quick introduction, and happy to go whichever direction.
I love that. Thank you for doing that, because it really does give people some context in what's going on and how much information, how dense this is. This is truly a transformative shift. This is not a new innovation, it's a general purpose technology. And the reality is, we're all exploring. We don't really know. We have direction. Maybe we have a compass and we have a North Star, but we really don't know so much. So it's interesting that the Swiss have created a model that's inherently Swiss, and I love that it's inherently Swiss, and that comes with a lot of every bit of the performative challenges that we have when we're independent. But also at the same time, it's inherently inclusive. And I think that scale and inclusion are two very, very difficult things to achieve as we move forward into general purpose technology. So let's kind of go there first, maybe. The inherently Swiss concept of trying to be neutral and good, but then also scaling with inclusion.
Yeah, this is a question that gets deeply philosophical very, very quickly, because when we say good, from whose perspective, what's the definition, and does good for one mean good for all, and those kind of things. So this becomes a very challenging question. Maybe you apply some kind of Pareto principle where you say 80% of humanity or something of that kind. But it's a fascinating question. So just a different concept from Anthropic. What Anthropic have done with their models of Claude and those other models. Those are based on a system called constitutional AI, which again, the idea is that there is a set of ethics, responsibility, bias prevention, those kind of elements, which are tied into how Claude is developed. And it's a model that has a high degree of morality built in. So it can absolutely work. And the Claude models are some of my favorite models to speak with, especially on things which are kind of gray areas. So it's absolutely possible to define to an extent what those moral codes are, and then build a model based on that. But will it satisfy every aspect of society? Probably not. And this is what makes developing these kind of systems very challenging, but also equally it makes it fun, and because it's a display of the diversity of humanity, right? And you want to try and capture that within the data. Training general purpose models on the public web, the risk is everything represented on the public web? And this is a question that I ask every leader I meet, that if AI is trained on public web data, the value creation will happen on things that are not on the public web. So this is again an important consideration for us going forwards, that the AI models are simply a representation of data sets in the public web and nothing beyond that.
I always say to people that it's true because I read it on the internet, and it's definitely true because it was in a Reddit thread.
Yeah, and it is fascinating, right? So if you ask any of these AI models, what kind of data you're trained on, you can get some level of generic response from them. And then you can ask a question, something like, do you think that humanity's features, characteristics are represented in your training data exclusively, or is there something beyond that? And like Claude, for example, will say that the training data is a aspect of humanity's multifaceted color palette, but it's not not complete, which is fascinating. Not to go into math, but this is Gooden's incompleteness theorem. You can only know what you know, but there is also an aspect of us which knows things are unknown. And training an AI model to say I don't know is perhaps the biggest challenge of our time now.
Perception is reality, right?
Yes.
That's sometimes, the models are very good at telling you what you expect to see back, so to speak, and it's just a mirror or a microcosm of a mirror. Yeah, trust and transparency and regulation and consensus inside of these is going to be challenging for sure.
Yes.
So why the Swiss? What did they like just at the highest level? Like, why is this inherently Swiss?
I think that, so, like all good things on the spectrum of cheese to Roger Federer, the Swiss have always done things with precision, and this is another example of it: excellence and precision in action. Some of the features which I like are the fact that you can actually see very clearly how the model is trained. You know that it is specialized in specific areas. You also know they're looking at greater well-being of society and the planet as we go forwards, which are ethical values that I'm sure most of us hold dear. And they're looking at how can this benefit the largest subset of humanity possible, not a narrow subset. Which is, these are all commendable features, I would say, within any cause. Forget AI models.
Yeah, so it was, when I was doing some of the research and looking through some of the stuff, it was basically the theme that kept coming back was ethics as a design constraint, not an obstacle, because we're designing these things right now, right? You know that
Yes.
I'm building and working in the model. And I think there's a very interesting distinction to be made there where you're talking about AI framework where you're tailoring or training or testing or targeting. But imagine if we could do that sort of like if we changed our systems, AI systems thinking into like the way we build our buildings with codes and standards and inspections, like what would that do? Like how would that change things if we tried to create this modicum of standardization across building a model, an AI model?
Yeah, this is so there are a couple of thoughts in my mind, right? So if we think about, if I can give a parallel to what happened with chess. So the original chess AI models were based on rules based programming. Then you had systems that were based on brute force search of games, and now you have systems that are based on neural networks. So this is a very, it's a beautiful parallel to what we are seeing across our world as well. So to give you specifics of this, pre Deep Blue. Deep Blue was an AI model developed by IBM, which beat Kasparov. Pre Deep Blue, you had systems that were rule based programs, and human beings could, perhaps at least the non novice players, could beat these AI engines. And Deep Blue comes along, and it's very clear once Deep Blue hits the market, although it is brute force based, which is there's no real intelligence in there, so to speak. It's searching a dictionary of games and it's looking up the best move and it's providing a response. So it's a specialized AI model on that front. So the brute force engine beats Kasparov. It's very clear, even at that point, that human beings are now second to AI. And then you have neural network based systems, things like Stockfish, AlphaGo, etc., have now moved to some kind of combination of brute force and neural networks, or purely neural network based. Leela Chess and some of these other models. The parallel that I see with our case here with Swiss AI is that Swiss AI is one of these specialized AI models. It's not a general purpose neural network like AlphaGo or Alpha Chess or Stockfish in the chess world. It's more specialized. And the bitter lesson in AI that I mentioned upfront, which is that as you go and you scale on generalized systems as opposed to engineered systems, the generalized systems will beat the engineered systems. Now the question is, will a generalized system beat the engineered system on ethics? Right. So this is where there are questions. We have seen that over engineering on ethics can have consequences as well. You've had public systems like Google's Gemini, where outputs were designed to be unbiased, but which indexed in a way which signified some type of bias. So this was a challenge that Google faced, and all system designers will face this problem as well. So this model, just full disclosure, the Swiss AI model is not yet public. We don't know how it operates. We don't know real world performance yet. It's supposed to be released shortly. Once released, we will know more. But it's a commendable attempt at developing something that's designed in a very different way than some of the other models.
Yeah, the hook that it gave me when I was doing my research was we've spent decades designing buildings to serve humans. What happens when we just start designing intelligence to serve society?
Yes.
It's just it's an unbelievable question, and there's no answer to that yet, and we're gonna have to sort of feel that out. But that's really where this starts to lean, right? Is designing intelligence to serve society.
Yes. Designing intelligence to serve society. Yes. Designing intelligence to serve all of humanity in a manner that allows us to shape and uplift all of humanity. I think it's a massive challenge. The concept of universal basic income. The opposite of that, in my view, is universal basic wealth or universal maximum income or something like this. That's what
And
we should be.
it might not have anything to do with money. It might just
Yes.
have something to do with access to information or pure data. I love that. Let's shift a minute. At what cost? I'm tracking about $7 trillion worth of investment, whether it's from the Mag 7 or more, on scaling data centers and all the infrastructure that it takes to do that, so that we can move into this age of intelligence through artificial intelligence, supporting all it takes to prompt and infer and maybe even predict with artificial intelligence. Again, you and I are in commercial real estate. We have to talk about data centers. We have to talk about what's going to support the actual physical infrastructure, IRL to the URL. Let's go there for a little bit. It's a scary world full of water and carbon dioxide associated with the build of these things.
Yeah, absolutely. It's where the bits meet the atoms, and this is what makes working in the real estate space fun as well, because you get if you ever walk through a data center, you're walking through an AI's brain. Right? This is a unbelievable experience. The scale of these things is reaching magnitudes that we haven't seen before. Meta's announcement, for example, is that image of a data center that almost spans the entire Manhattan island, right? So that incredible size and scale that we're building to. MIT concept, and Chris, we were briefly touching on this, computronium, basically designing every element on Earth to be maximally beneficial to compute. Now the question is that what we want to do, right?
Very good question.
I see that with any of these kind of technologies, there is typically a scaling period where larger means better. And then over time, efficient means better, and it's kind of a back and forth on that front. So I see that we are in a scaling period right now, and as we go forward, some of these model architectures, techniques to developing these AI models, etc., will scale downwards, and we will have edge based compute. We'll have small language models that run on devices, etc. So there's over the next 3 to 5 years, we will see all of these kind of elements come into our environment. There's also distributed computing and how you power these data centers. I was watching this news report on CNBC where a data center is being powered by used EV battery power packs based on using solar energy and those kind of things. So there's innovation happening on this front. Also, this may seem like science fiction, wild thought. Consider that every autonomous vehicle is actually compute, and if you could somehow cluster all of those in idling time and stitch them together, now you have a massive global data center made up of these electric vehicles, autonomous driving vehicles. So there's a lot of interesting new ideas that are coming up, and then to take it literally into outer space, you have space-based data centers also being floated as ideas. There's lots of innovation happening on this front. So I see opportunity space and possibility space expanding even within the built environment, and how you can develop these systems, how you can make them sustainable, how you can power them in a way that are more efficient, and how you can kind of scale up and scale down depending on need.
So let's go a little bit more macro on this for folks that haven't really thought this through a little bit, or maybe are new to the concept of compute for AI, and help me to fill in some additional blanks that you may have. There are three basic elements right now for AI compute. It's the kilowatt hour because we need energy and electricity. We've got max and flops associated with the compute, the actual processing of the information. And then we've got storage, terabytes, petabytes, whatever it might be. Those are the three basic elements associated with AI right now: kilowatt hours and energy, max and flops associated with the amount of compute, and then of course storage. Is there anything else that you see basic to the chemistry or the biology or the physics behind the AI co-location center?
You could add inference time in there. I don't know if that gets covered by the compute element. So just to take a little bit of a step back, the model. So if you think GPT, the P in GPT stands for pre-trained. So the original scaling that happened in the dark ages of 2021 and 2022 was pre-training and the scaling on that front. And then these companies, they realize that actually there are different architecture that you could apply, where you scale the time the model thinks before it responds. So these are your so-called reasoning models. So they're scaling inference time essentially. That's another area where you could scale. And then you had DeepSeek come up with a different model architecture, which made it more efficient. So you could take that more efficient architecture, you could take the previous pre-training, you can take the inference time compute and scale all three. And now you'll have further leaps. So we are seeing innovation on that front as well. So the three that you mentioned plus inference time, I would add there.
Yeah, it's like the technology leapfrogging is really, it's really amazing. Yeah, so energy stocks are inflated right now. That's one place that people are looking to invest. We know that the basic infrastructure in energy is going to be super important that we figure out. Our grid, through my research, doesn't necessarily have a generation problem. We have a capacity and distribution problem here in the United States. So I think it's interesting to rip that apart just a little bit before we move on. We've got small modular reactors, we've got off-grid nodes. There's lots of ways for us to harness the energy that we need to push these models. But I think it is safe to say that here in the United States, our challenge is not generating the energy or the electricity. It's actually the capacity to distribute that energy. Have you seen some of that yourself?
Yeah, this is true, Chris. I would say for more or less almost every country, not just the US, where you can generate the energy, but can you distribute it? Because sometimes there are places where you can generate it, but the cost of transmitting that energy is significant, or the energy loss in transmission is significant, and you're not able to utilize it. So there is innovation required on that power grid front as well, and that's one of the biggest areas. You need to generate more power, but then you also need to distribute it effectively. And you don't want a situation where AI models are competing with human beings, air conditioning units in people's houses versus some teraflop training in a data center or something like this. That's not the math that you want to be doing. You don't want to make it untenable for households to buy electricity as well, because these large companies can outbid a household. So you don't want that situation. So there's a community angle to this, which is very important to consider. So distribution for sure. So as JLL, we are advising companies on this front as well, from a portfolio planning, power grid situation, location, those kind of things, which is becoming extremely important. Many of the companies we're working with are developing 20-25 year plans on this front right now.
Yeah. So that's the energy side, which is very interesting and fascinating with both renewables, traditionals. I think we need all forms of energy. It's really a capacity and a distribution problem to solve more than it is generation. That's my personal opinion. Moving into process, it's about rare earths, right?
Yes.
We can only slam so much electricity through rocks. We have to have those rocks. So what about that? What's our capacity? What's the global capacity right now of rare earths to create the chipsets that we need to push this compute?
Yeah, like with everything else, there is I see the biggest constraint as electricity, power generation, those kind of things. Secondary constraint is chips and the supply chain associated with chips, whether that's raw materials or manufacturing. That's a secondary constraint. So if you look at Eric Schmidt recently said that we are using something like 3% of global electricity for AI, and we may need 97% of global electricity. It's a massive number. That of course assumes that we don't increase the capacity of electricity generation. So we'll have to increase the capacity, and then Elon Musk has said as well that we'll run out of electricity far before we run out of chips. So I see the first problem as being electricity. Problem is rare earth. Where do you source it? How do you bring those materials together? There is only like 1.5 companies on earth which do those things well from a supply chain perspective. So that those are bottlenecks. Are there alternates being created? Are there chip design related alternates being created? These are all areas which require innovation. I also see that AI can help on this front. So, for example, Microsoft released a model called MatterGen. So, Microsoft MatterGen model does for material science what AlphaFold does with organic chemistry. So basically, you can design new materials using MatterGen, Microsoft MatterGen. Really cool technology. So those kind of things being developed by AI can help us as well with respect to more efficient chip design, efficient material engineering, etc. Yeah, I see rare earth and those kind of elements as being secondary to electricity generation.
Yeah, the last one, Ram, is water, which I
Yes.
actually see probably as the biggest challenge that we face. A lot of the data centers that I'm seeing proposals for are in arid places that already have concerns for freshwater source supplies. So obviously, we've got a huge body of ocean. So, and then natrium SMRs, salt based, salt cooled modular reactors. I think I saw, like, it's been a while now, you see these statistics. It takes 2 bottles of water to run a traditional prompt because our systems are still not closed systems and we have to water cool, a lot of these data centers. Have you seen any advancements or innovations in cooling systems that do not have such a huge demand on water?
I think we'll have to, given we are developing city-sized data centers, we will have to rethink some of these liquid cooling techniques. And I'm confident we'll have better, more efficient techniques going forwards. I can tell you for sure that every company we are working with, be it the big tech companies or some of these infrastructure development companies, they're heavily focused on sustainability as a concept, and ensuring that you start with that, and it's not a fifth or sixth bullet point in your strategy to develop a data center. It's a heavy focus area. We are working with, just to give you a couple of examples, JLL examples are, we have our own systems called Hank, for example, which allows you to do better HVAC related planning, and it's able to save energy by 18 to 22% for our clients. You have Carbon Pathfinder, which is a technology that we've deployed on sustainability, decarbonization of footprint, developing some of those scenarios and strategies, bringing in data where data is missing, etc. These kind of innovations stitched together will be important as we go forwards in developing more sustainable infrastructure. It's a very important consideration and must be. I don't. We've never had a single conversation with a client who said, "Ability, never mind, we'll think about it later."
Right.
It's a logical starting point, and almost every company is giving it due priority.
Yeah, and that's, I appreciate you highlighting that because we actually have new ideas and designs now that we have artificial intelligence. So, the old way of trying to create operational efficiency inside of an inefficient structure is an old construct. So we
Yes.
can continue throwing good money after bad, or we can design better systems, design better buildings, design to building science standards rather than code,
Yes.
design to performance standards rather than designing to merit-based achievements associated with the way the build happened. So I think it's really interesting. Our friends Jeremy and Mark over at Thinking on Paper have had a lot of conversations around this, and how quantum can potentially solve some of our problems through natural solutions, right? By taking a look at the complexities of our natural systems, biophilic design, and applying them to what we build as humans. We have to reorient ourselves a little bit to understand that we're part of nature, not controlling it, and that's hard. But at that same time, if we put ourselves back into that mix and we start to use some of these intelligent automations and some of these intelligent perspectives, we actually come up with whole new designs, right?
Yes. Yes, absolutely. The statement is every species on Earth is sustainable. The human species is the only one that's trying to be sustainable and failing.
We're a hot mess, aren't we? Like
We,
we just can't get out of our own way.
yes. And if there were something called nature's computer, it's essentially quantum computers. All of our so called reality is based on some form of quantum computing, quantum mechanics. So we can absolutely learn. I'm just cautious, Chris, that I don't want to answer an unknown with another unknown. So we don't know right now how quantum computers will impact all of these things. There is tremendous potential there for sure. I think we're still 3 to 5 years away before we see any real solutions, and I'm sure you're not doing this, and I'm sure none of the companies we are working with are doing it either, where they're saying we'll wait for quantum computing.
No, no, not waiting at all. In fact, that's a good transition into our last sort of like 15 or 20 minutes, Rom. When I've got a speech called AI Accelerating Innovation, not artificial intelligence. And a lot of our conversations in the past and the conversation you had again with Jeremy and Mark on Thinking on Paper was about exponential innovation. And, I think that we're real early on additive innovation. I think we're still almost in an R&D world. Whereas we understand and recognize the benefits of open source and crowd thinking and crowdsourcing and the benefit of having a lot of good ideas rather than just one good idea through a bunch of experts. But we're moving into a time where we can, with assistive technology, take advantage of exponential innovation. And you give a great analogy of that with your steps. Would you do that? Would you take our listeners through that again, the 30 steps, I believe it is?
Yeah, yeah, it's a fantastic analogy that I heard from Peter Diamandis on the Singularity Abundance 360 stage. So we hear this idea exponential thinking, exponential technologies all the time, and it's a contrast with linear, and it's very difficult for our minds that are based on linear thinking to understand the exponential. So if you were to ask a question like, if you took 30 linear steps, 1 foot at a time, how far would you be at the end of 30 linear steps? Easy answer, 30 feet away. Now, if you ask the same question, except now you take exponential steps. So step 1 is 1 foot, step 2 is 2 feet, then 4 feet, then 8 feet, then 16 feet, then 32 feet, and so on. How far do you think you are at the end of 30 exponential steps? And most people will say, oh, many million miles or something like this. It's a very large distance. The answer is you're 26 times around the earth at the end of 30 exponential steps, not a million exponential steps, just 30. So this is the difference between linear and exponential. And the challenge that we have is that we are living at a time when every technology that we're looking at is accelerating exponentially, whether that's AI or robotics or AR, or on the other side of the coin, cybersecurity risk, shadow AI use, bad actors. All of those are accelerating exponentially, and they are cross pollinating. They are creating amplitude resonance between each other. Converging combinations are increasing in speed. So this is a massive shift in how we should be thinking about the future. And I've kind of learned to force myself to say, if I think it's 5 years away, it's probably going to be here in 3 months, 6 months, something like this.
Yeah, no kidding. I've stopped telling people what I think about time because, my research on ordinal versus cardinal has taught me that with exponential thinking, time is relative. And that's one of those weird things that a lot of people forget what Einstein was thinking about when he did E equals MC squared. It was really thinking about the theory of relativity of time and space.
Yes.
That's not two dimensional. That's vector. That's multi-dimensional. And time doesn't care in that world.
Absolutely. I mean, I'll give you this practical example. I wrote an article titled Navigating the Next 1000 Days in a Shape Shifting Landscape of Technology. I wrote it in January 2024. 1000 days. The ideas that I spoke about there were agentic AI. January 2024, no one was talking about it. When I wrote it, people are like, agentic AI? What is this? Did you mean angelic? Are you misspelling something? Not sure what you mean. Um, Now it's real and it's everywhere. I had spoken about a billion AI powered citizen developers, basically no code, low code AI, and everybody becomes a software engineer. And people are like, you're crazy. It's never going to happen. Already here. Vibe coding was not a thing then. Now it's a thing. I had spoken about AI influencers. Was not very big in January 2024. Now it's everywhere. Mia Zilu was at the Wimbledon. Mia Zilu is not an actual person, it's an AI influencer. She, for every photograph that she puts up, there are 200 to 500,000 people commenting, reacting to those pictures. Incredible. I had also spoken about the other side of this, which is solitude, not loneliness, but solitude. Time with yourself becoming very important as you go forward, because that's where you can make connections across these ideas. If you look at the some of the foremost thinkers of history, whether it's Einstein or anyone else, or the foremost thinkers of our time, like Yuval Noah Harari or these folks, where do they get their ideas? You ask them and they say it's in solitude. And no one was talking about this in Jan 2024, but now it's become a thing. And my projection was 1,000 days, and we are not even halfway through those 1,000 days, and many of those things are already real.
I made the mistake of there was a dinner that was hosted. It was actually a lunch that was hosted around the holidays last year. And my theme was to try to it was heads of global real estate, and I was here in Charlotte, North Carolina, so a lot of traditional finance, accounting, and banking, legal sort of heads of real estate. And I challenged them with the Chris Dixon's book, Read, Write, Own. I don't know if you read that, but the transition just from the internet and Web 1 to Web 2 to Web 3. The predictions that I made there, I was totally wrong with Web3. So, I said that they probably had 3 years. And in fact, the response was within 6 months. So I've learned that my macro perspective on these things doesn't include time, because I've made too many mistakes and I'm too honest about those mistakes, because people say when. And the answer is now. It's now. And I ascribe to Long Now Foundation. I'm a member of the Long Now Foundation, Stuart Brand's work. And I think what can we do now for the long is the way that we need to be thinking about these things, because there is no real when. When is now.
Yeah, absolutely. This is very similar to the future is already here. It's just not evenly distributed, and we have the power of all of these technologies right now, and we can do some amazing things with them if you want to do it, and if you put in a little bit of effort. Now you don't even need tremendous amounts of effort to learn these technologies. It's just so easy to use. Many of these technologies are free. I cannot believe that we have something like Google Gemini Deep Research available for free, or Perplexity, or these tools available for free. I mean, one of the very simple examples, Chris, I'll give is Perplexity is now on WhatsApp, and you can literally chat with Perplexity on WhatsApp. So if I receive a comment or news alert from someone on WhatsApp, the first thing I do is I fact check it with Perplexity. I simply ask Perplexity, "Is this thing real?" And then
Right.
Perplexity will come back with insights. And you could even set up things like daily news alerts or summarize news events, or those kind of really cool applications, and free. I can't believe some of these things are available for free, and they're so powerful.
Yeah, and yet we pay for subscriptions to traditional media information, right?
Yes.
And the media model has changed and will change. There's a really interesting talk on that Long Now Foundation from a person called Kay Alato McDowell about neural media. A very interesting talk. If you haven't heard it, the concept is that there's every 30 years media changes, and it went from network media, broadcast media, to network media, to now neural media.
Hmm.
And we're really entering into this time now where we are some years into neural media, but neural media is really more predictive. When you walk out of the grocery store and you have something in your basket that you didn't think you would buy, but you bought, how predictive was that? That was pretty predictive. And you're starting to see dynamic pricing. We saw that on the airlines last week.
Yeah.
The airlines don't need to, we'll keep them anonymous. But, because Ram can pay more to come visit Chris because he's got financial means Ram pays more.
Yes.
So this notion of neural media is starting to sink into the economy a little bit as well.
Yeah. I mean, every aspect of our being is being changed. It is actually very interesting how predictable our behavior patterns are. You know, the challenge has always been: do you have access to all of that data? Can you model that data, and can you output a prediction in time for it to be used in the right way? And I think with some of these AI tools, you can absolutely engineer those things to create successful outcomes for everyone.
So let's take 10 minutes and go to the economy, and let's go back to capitalism, because we all have to eat. So, we talked about opportunities potentially for investing in the infrastructure behind what the new AI co-location center looks like. But we haven't talked about the emerging world of stablecoins and real world assets. Here in the United States, we have the Genius Act that passed into law a couple weeks ago. We haven't spoken since then. And you know that I'm a longtime student of cryptocurrencies. And I just want to talk about the opportunity that we're facing with economics converging on real world assets, being that we're both in technology and we're both in commercial real estate. Let's take a few minutes and unpack some of that.
Yeah, firstly, full disclosure, I'm an investor in places like Coinbase. I own cryptocurrency myself, so I have a bias in this point in this discussion. I see this as a fundamental building block, whether it's blockchain, whether it's cryptocurrencies, whether it is decentralized autonomous organizations, whether it's distributed work. I see all of these as being building blocks of the future, that future not being 10 years away, the future that we are in right now. So I see these as very, very important as we go forward. We are in a transition phase, Chris, is the way I look at it, where we have both of these physical and digital systems. And some economies are moving forward very rapidly on this front. Like, for example, in India, they've launched digital addresses right now. So you don't need a PIN code anymore. You have a digital address for every location. Things like this. In the Indian economy, for example, you have digital wallets available where you can make payments. Even very small local vendors who just have a cart where they're selling bananas or something. Even those folks are accepting payments through Google Pay and what's called UPI, Universal Payment Systems. These are prevalent and they will accelerate. Same is true for China through WeChat. Through a super app, you can basically make payments for almost everything. So I see it as a fundamental building block. It'll allow us to accelerate access. It'll allow us to distribute wealth better. It'll allow us to solve for seemingly crippling issues like copyright and patents and intellectual properties, etc. Some of the laws around those are designed for 19th century printing press and not 21st century or even 22nd century technologies that we have access to right now. So I think there's a lot of innovation that you can unlock once you have these kind of technologies available at scale.
Yeah, and it's strange because in the United States we have a very USD central bank perspective, but when you look at things globally and you look at how the way global money moves, that's what brought me into cryptocurrency was remittance. I was watching folks pay fees to cash checks and then pay fees to send money. And looking at the amount of money that they were losing, the amount of energy that was happening, loss of value in those two exchanges was tremendous. It took me down the whole path of remittance, $905 billion industry globally, and almost 6% of all transaction fees average $500. About 6% of that comes out in fees. And yet there's peer-to-peer exchanges that have been out for 20 years that don't have that are not subject to fee exchange. Just that story and looking at the remittance world and just that industry, just that part of global finance is fascinating.
Yeah, and right here we have another example of like amplitude magnification across these technologies, because we discussed data centers in the context of AI. What about cryptocurrencies, stable coins, decentralized organizations, distributed compute? All of these things also will require some kind of physical world infrastructure. So the bits are meeting atoms everywhere.
Yeah, it looks like we've got our third conversation teed up now because, why DAOs don't work. I think we could just have that conversation why they haven't worked, but why they probably will work and how many, rails have been created and how much infrastructure improvement there has been, the things that people don't realize when you can't see it and how real it is. It almost feels like magic.
Yes, absolutely. I'm sure we can do easily an hour on that subject. It's a subject that I'm deeply interested in. So happy to reconvene on that, Chris.
Well, it'll have to be season 4, Ram. You're just at season 3, guest number 2. Listen, I appreciate your time. We're on an hour again. Thank you so much for breaking down our Swiss AI, giving us an update on all the craziness that's happening, which is amazing. And then, we got a chance to talk about opportunities inside of the increase in infrastructure around AI, plus the impact that it's having with the social impact that's having. So, Ram, this was a great hour. I thank you again for your time. And it's a holiday for you in Canada.
Awesome. Thank you for having me back on, Chris. And I look forward to our next season 4 conversation. And of course, I'll share I share updates almost daily on this subject. It's moving so quickly now.
Yeah. Thanks a bunch, Ram. I appreciate you.
Thank you. Thank you.